Hello everyone, my name is Annika Smith, and I'm back with the fourth video of the Stat 231 series. So in this video, we'll be covering more of the Chapter 5 content. This one is about using the chi-squared distribution for our hypothesis tests. So you would find examples like this, say you're testing something for the exponential distribution using the exact pivotal quantity, that one would use chi-squared. Or if you're doing sigma for the Gaussian distribution, some hypothesis tests based on that, you would also use chi-squared. So I want to show this one because it's like slightly different than what we would see otherwise. So let's hop right into it. We have that the Stat 231 Piazza is fairly active with an average rate of one post every 3 hours, and over the last few days, the following 20 wait times were observed, and we can see the values there. And then we have some extra information that might help us, and we want to use a hypothesis test based on the exact pivotal quantity to determine whether there's evidence against the average rate. So, in order to do that, as soon as we see hypothesis tests, we should be thinking of this 5-step kind of process, and you should have it written on your cheat sheet or memorize it or whatever floats your boat. But I just have it right in front of me here. So first thing we want to do is determine the model. And that's pretty easy for us because it's given right in the question. So we don't have to do any sort of thinking about that. So we just say that our yi's are modeled by the exponential distribution. And then from there, we have to state our hypothesis. So sometimes you might be given something in the question that says, like, let our null hypothesis be this. But here we're not explicitly given it. We're just told that we want to determine whether there is evidence against the average rate. Well, what is the average rate? Well, it's one post every 3 hours. Since everything here is measured in hours, our theta, as defined in this class, should be 3. If you're confused about how I got this, it took me a little bit to figure out too. Not 100% sure if it's right, so we're just going to go with it. And if I'm wrong, then someone will correct me, I trust. So we'll just continue on with that. And with our alternative hypothesis, we just care about whether the average rate is or is not 3. So we just want this to be not equals 3. We'll be doing a two-sided hypothesis here. So now that we have determined the model and stated our hypothesis, our next step is to solve for the test statistic. So in order to do that, you should have something like this written on your cheat sheet. I just stole this directly from the horse notes, so you can find this in the summary of chapter 5. But I have that the exponential, we have this u here is 2n y bar over theta naught. So I can just use that as my exact pivotal quantity, because that's what this is, exact p-value, you can see up there. So what I'm going to do is calculate, oops, wrong thing, little u is equal to 2 times n times y bar over theta naught. And then, well, what's y bar? Well, I have it written right on my cheat sheet, or you probably remember it by now. It's the sum of all the yi's divided by n. So if this is the sum of all the yi's divided by n, then surely I can just cancel out the n's here. So this is just going to equal 2 times the sum of the yi's over theta. So we have this given right here, the 60.81, and then we can do 2 times 60.81 divided by 3 because that is our null hypothesis theta. So I can calculate this in RStudio. I've got it up here. See, I didn't cancel out the ends here, but that's fine. They'll just cancel out anyways. And we get 40.54 as our value of little u. And then, so we got the test statistic. Now we need to solve for the p-value. In order to do that, I wanted to show this specifically for this step because it does look a little bit different than you would normally see in hypothesis tests. Essentially, because the chi-squared distribution is not symmetric, we can't use the two, like normally we just multiply whatever probability we get by 2 and that's our two-sided. That's because the tails are going to be equal on both sides. But because the chi-squared distribution is not symmetric, has like a little skew, kind of like that, we have to use this different thing, which I have written on my cheat sheet here. You can see it right here. I find this kind of like weird looking to me, so I kind of just write it like this instead. for hypothesis tests with the chi-squared, the p-value is going to be one of these two things, and it's just whatever is actually a probability, because you'll find that one of these numbers is always going to be greater than 1, and the other one will be something in between 0 and 1, so you just want to go with the one that is actually a probability, like between 0 and 1, instead of one that's like over 100%. So what we do is compute. I'm just going to compute both of them depending on what we're given on the actual exam. We're not sure what this would probably look like, so just compute whatever you can of u greater than or equal to u and u less than or equal to u. And then we're just going to figure out which of these is actually a probability and go with that one as our p-value. So this is not too bad to do. I just want to hop over here and note that this is actually pretty key because I also forget to do this, but we are modeling this off of a chi-squared with 2n degrees of freedom. So a lot of the time we see n minus 1 degrees of freedom, but that is not the case for the exponential. It is actually 2n degrees of freedom. So you have to keep that in mind when you're doing this. So our n was 20, so I just put degrees of freedom is 40, n times 2. And then when we calculate this and this, we can see that our second value here is actually between 0 and 1, whereas the first one's over 1, so we can't use that. And I also wanted to demonstrate, in case you don't have this lower dot tail equals false business, you can just take like the other side of the probability by subtracting 1 minus the lower tail probability to get the exact same value. So you can see those are equivalent. And we go with this as our p-value, so 0.8929. Okay, so I want to go back to my work over here. And our p-value is 0.829. Something like 892. Man, 893. So with that, this p-value looks pretty good, pretty large. I don't think I'm going to get any conclusion from this, but we can just scroll down to the table that'll be given on the exam just to see. And we see that, okay, this p-value is greater than 0.1, so we have no evidence against H naught based on the observed data. So I just stick that down there, no evidence against our average rate, and then we're done. So I hope you enjoyed this video. I hope that makes sense in terms of how we use the chi-square distribution for a hypothesis test, because it's a bit different in terms of we can't just take like 2 times the probability, because the probability on either tail is not going to be equal. So we have to look for, okay, which of these is actually a probability, but that's essentially all there is to it. And other than that, we just follow our basic steps, write our conclusion, and then we're done. So thank you so much for watching, and I look forward to you seeing my next video. Bye bye.